These are the notes for Algebra 2. We're talking about solving quadratic equations by graphing. Now, this is not a section directly out of the textbook. We're instead going to be talking about this sort of on its own, and we'll pick up with the textbook a little bit later. Now, when we're talking about solving quadratic equations by graphing, we're talking about looking for the x values of the equation when the equation is equal to 0. Now, what that looks like for us is that if I have a function such as y equals x squared plus 6x minus 7, the solutions are given where y is substituted with 0. So I take y out, I plug 0 in like I did here, and y becomes 0. I solve this equation for x, and I get the solutions to the equation. Those would be the solutions for a quadratic function. Now, we'll see how that works using graphs in just a moment, but first I want to look at some vocabulary really quickly. Now, the first thing we want to think about are roots. Now, the roots of a quadratic function are the x-intercepts of the function. And of course, we know that the x-intercepts are where y equals 0. Not surprisingly, that's pretty much exactly what we were just talking about. We replace y with 0 because we're interested in where y equals 0. So we're interested in finding the x-intercepts. The zeros of a quadratic function are where y equals 0, thus the term zeros. In other words, we're looking for the x-intercepts. These are also the roots, so very much the same thing. Finally, the solutions to a quadratic function are the roots, or the zeros, or the x-intercepts. We have 4 different terms, all mean exactly the same thing. So we can use them more or less interchangeably. Now, there are some times when we would prefer to use the term roots versus zeros versus solutions versus x-intercepts. But for the moment, I'm just going to be using all of them interchangeably. Now, we want to start by finding the zeros of this quadratic function. So we look at our function, and what we're interested in is where it crosses the x-axis. So we can see it crosses the x-axis here and here. These 2 points are the zeros of my function. And my zeros are, in fact, at 1 and 3. And that's it. Done. That's all I needed to do. Find where it crossed the x-axis. Now, I would like to graph an equation and find those points. Now, to start with, I'm going to graph this equation. Now, this equation is in intercept form. We can tell because we have 2 sets of parentheses and none of them are squared. And of course, we know intercept form is in that form x minus p times x minus q, where p and q are numbers that we're interested in. And in fact, p and q are the x-intercepts by definition. In this case, p is negative 4, and q is negative 3. So, I know my solutions already. My solutions are where the graph crosses the x-axis, where the x-intercepts are. And I know that those 2 points are negative 3 and negative 4. Those are my x-intercepts. So those are my solutions. Negative 3 and negative 4. So really, I'm already finished. I'm going to take a minute, though, just to graph this, just to sort of remember how we're supposed to graph these things. Now, we start by finding p and q, and then we say, all right, well, we want the point directly in between them. So we find the average of p and q, add them together, we get negative 3 plus negative 4 divided by 2 equals negative 7 over 2. which is negative 3.5. So that gives us the x value, that gives us our axis of symmetry, is at negative 3.5, which is directly in the middle of these two, as it should be. I've got my axis of symmetry. Now I want to use that to find the y value. Remember, the y value is going to sit on the axis of symmetry. So what I'm going to do is I'm going to take this x value and I'm going to plug it into the original equation as x. And that will tell me what the corresponding y value is. So I'll change x with negative 3. So I get negative 3.5 plus 4 times negative 3.5 plus 3. And when I do that, negative 3.5 plus 4 is 0.5. Negative 3.5 plus 3 is negative 0.5. Now I multiply those together and I can use a calculator to get this done. And I know that this is negative 0.25, which is negative 1/4. So a quarter of the way between 0 and negative 1. So on my graph, I'm going to plot the point negative 3.5, negative 0.25. And like I said, it's going to be on the axis of symmetry, and it's going to be a quarter of the way between 0 and negative 1, which is about right here. So I'll put the point in. Now I have my vertex, I have my intercepts, I can graph this. Now, of course, this was just to graph it. I can already tell, and I already knew, that my solutions were negative 3 and negative 4. Alright, now we want to graph this function and find the roots. Now I'm going to leave you to do the graphing yourself. I just want to help you set it up. Now this is in the form y equals ax squared plus bx plus c. Now as we remember from ax squared plus bx plus c standard form, we find the x value, the axis of symmetry, by using the formula negative b over 2a. So a is negative 1, b is 4, and c is 0 because it's not there. So I plug these in. I get x equals negative 4 over 2 times negative 1. I have a negative on top and a negative on bottom. Those automatically are going to change into positives. And I'm left with 4 over 2, which is 2. So my x-axis, or my axis of symmetry, my axis of symmetry is x equals 2. Now, you will need to use the axis of symmetry to find the y value of the vertex, then find some other x values like we've done before, graph the equation, and see where it crosses the x-axis, where the roots are. That's your job. You'll need to bring that into class completed tomorrow. Now, keep in mind, I will tell you this, that the roots that you get, the solutions that you get, should be whole numbers. You should not be dealing with any fractions when you find the roots. So keep that in mind when you're graphing and when you're plotting points. All right, bring this into class and make sure that you have it done.